Hello. In this video, we're going to go ahead and graph another function. Using transformations, graph the function following the steps provided in class. So we have the y equals negative square root of x plus 2 plus 3. Excellent. So let's go ahead and identify the parent function. The parent function is going to be y equals the square root of x. Writing down the table for the square root of x, x begins with 0, then 1, then 4, then 9. Wonderful. The y's are 0, 1, 2, and 3. Looking at this, we have different transformations. There is a transformation right here on the outside of the radical. That's going to give me y equals negative square root of x. And that'll give me a new xy table. Now, notice that the negative is on the outside, so it affects the y value. And since it affects the y value, the x values will stay the same. And notice that it is a negative on the outside, so it changes the y value signs. That's going to give me 0, negative 1, negative 2, and negative 3. Another way of thinking about this is that there's a negative 1 out front, so you're going to multiply the y values by negative 1. So 0 times negative 1 is 0, 1 times negative 1 is negative 1, 2 times negative 1 is negative 2, 3 times negative 1 is negative 3. Excellent. And down here I'm going to keep track of the transformations. Now notice that this is a reflection, and it's a reflection across the x-axis. And the reason it's a reflection across the x-axis is because the y values change, the x values stay the same. So whichever value stays the same, that's the kind of reflection it's going to be. So if the x's stay the same, then it's a reflection across the x-axis. If the y values stay the same, then it's a reflection across the y-axis. Good. Next, let's look at the plus 2 there. So we have y equals negative square root of x plus 2. Notice, again, we get a new table out of this, and we get a new table because, well, frankly, that plus 2 is inside the radical, and it affects the x values, so all the y values will stay the same as the previous one. So we're going to have 0, negative 1, negative 2, and negative 3. So 0, negative 1, negative 2, negative 3. Now that plus 2 is technically a minus 2 horizontal shift. And the reason that it's a minus 2 is because it's inside with the x. If it's inside, you do the opposite. In other words, we are subtracting 2 from all of the x values. That gives me negative 2, negative 1, 2, 7. Fantastic. Now for the last transformation, that plus 3 there. That plus 3, whenever I add it on to here, is in fact the original, it's going to give us the original equation here. And this table will be the table that I graph. Notice that the plus 3 is outside of the radical, which means that it affects the y value, which means that the x values will all stay the same from the previous graph. So we'll have negative 2, negative 1, 2, 7. And this plus 3 is a plus 3 vertical shift. So we're going to add 3 to all the y values. So 0 plus 3 is 3, negative 1 plus 3 is 2, negative 2 plus 3 is 1, negative 3 plus 3 is 0. Outstanding. And at this point, we simply graph that last table, negative 2, positive 3. Negative 1, positive 2, 2, 1, and 7, 0. There we go. Notice, though, that this is always the beginning, and it's going towards this way. So if we were to look at this, we start here and go towards the rest of these. And that's what the graph is going to look like. Now, we do want to look at the domain here. For the domain, this is a square root, which means whatever's underneath the radical. In this case, x plus 2 has to be greater than or equal to 0. Subtract 2 means x is greater than or equal to negative 2. Notice it starts at negative 2 and goes to the right. So the domain here is, in fact, negative 2 to infinity. And this is the reason why your final graph should start at negative 2 and go to the right. Alrighty. Well, I believe that's it for this particular video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.